Hello friends, welcome back to my YouTube channel. Today I'm going to solve LeetCode problem number 142, linked list cycle 2. So in this problem we are given the head of a linked list and we need to return the node where the cycle begins. If there is no cycle, we are just going to return a null value. So let's see how we could solve this problem. We are given these three examples. I'll be explaining these three examples before we look. But before that, let's look at this example here which I created. So I have created 7 nodes here. Node 1 is the starting node, so this will be where our head points to, and then now we each of the node points to the next node. So 2 points to 3, 3 points to 4, 4 to 5, 5 to 6, 6 to 7. And what would 7 point to? Well, if there is no cycle, then 7 would point to a null value. If there is a cycle, then 7 would point to some value in this node. Let's suppose that 7 points to the value to the node 4. So that would mean that this linked list has a cycle. So the starting point of this cycle, as you could see, is 4, because what happens is we move from 1 to 3, 4, 5, 6, 7, and then from 7 we go back to 4 again, and then we start the cycle again. So we again go to 4, 5, 6, 7, and then we keep on infinitely going over this loop. So that's why 4 is our starting point of our cycle. So that is what our answer would be, and we need to find this starting point. So how could we actually find this starting point? So for solving this problem, we are going to use Floyd's algorithm. So Floyd's algorithm uses 2 pointers, that's a slow pointer and a fast pointer. So what is a slow pointer and a fast pointer? A slow pointer only moves 1 step at a time, whereas a fast pointer, it moves 2 steps at a time. So we are going to use these 2 pointers. So first of all, both the slow and the fast pointer will point to the beginning of the node in the linked list, and then next in every single step, every single move, that is slow pointer moves 1 step and the fast moves 2 step. So slow pointer moved from here to here, that's 1 step. Fast pointer moved from here to 1 to, that's 2 step, right? Now again, next what happens is slow pointer moves from 2 to 3, that's 1 step. Fast pointer moves from 3 to 5. In the next step, slow pointer is here and fast pointer is here. So what's happening is now we are entering the loop. Once we enter the loop, there will be a point where both the slow pointer and fast pointer will meet. So that's the point where we know that there is a cycle. So let's keep on moving. So we are here, slow will move to 5 and fast is now. So we moved 2 steps, right? So from 7 we move to 4, that's 1 step, and 4 to 5, that's the next step. So from in 2 steps we reach the node 5. So now both of our slow and fast pointer is at the same position, right, at the same node. So now we are sure that there is a cycle in this linked list. If there was no cycle, let's suppose if, okay, so let's undo this thing. All right, so if there was no cycle, if we didn't have a cycle, and that would mean that 7 would point to a null. So in that case, what would happen is fast would end up in a null value, because while it's in its next move, it would end up in a null value. So that is when we'll know that it doesn't have a cycle. But here in this case we have a cycle, and both fast and slow met each other at this point, at this node. So we know that there is a cycle now. To find out the starting point, what we are going to do next is, so we okay, let me just clear things up. All right, so to find out our starting point, we already have our head pointing to our the first of our list, right? So now we are only going to use our slow pointer here, and then we are going to only move one step at a time, and the point where both the head and the slow pointer meet is the starting point. So we move the head one at a time, one step, so it reaches point node 2, and then the slow pointer reaches node 6, and the next move head is at node 3 and slow is at node 7, and in the next move head is at node 4 and slow is again at node 4 here. So now both of them meet at this point, and that point is the starting point, the starting node of the cycle. So we have found our answer, and we are going to return this value from our node. So now we know how we could solve this problem. Let's look at the example given in this problem. So for this we would need start and fast pointer, right? And we already have our head pointer pointing to the linked list, the first of the linked list. Now start moves one step and fast moves 2 steps. So we reached here. In the next step, start moves 1 step. We have not yet met and first moves 1 and 2 steps. So that would mean they are here. In the next step, start moves and reaches here, and the fast moves and reaches here. So at that point, now both of them are at the same node, right? So that would mean that there is a cycle, and now we have to find where they meet. So now we are only going to use our head and our slow pointer. So in the next move we are only going to move one at a time. So head moves 1 step, reaches this point, and start moves 1 step and it also reaches this point. So we found our starting point of the cycle. For this example, the starting node itself has a cycle, right? But still, let's see how this problem is solved using fast and slow pointer. So now our fast and slow pointer are pointing at the same point. However, we need to make sure that it's a do while loop, not a while loop. So we are going to use a do while loop for this problem. So we make a move initially. So slow is here, and the fast again makes 2 moves. So fast from 1 to 2 and then from 2 to 1. So fast again reaches the same position, and the next moves slow is at node 1 and fast is again at 1. The one move to 2 and the next move to 1. So fast is again at the same point. Now that is where they meet. Now in the next move we are going to use the head and the slow, right? But for this move we are going to use the while loop. So in the while loop, since the condition is that while head is not equals to the slow, but since they are already equal, we know that we found our answer, so we are going to return that value. And in this case there is no cycle. So what happens is fast and slow. Since fast is pointing, the next of the fast is null, so we would return a null value since there is no cycle. So now let's start coding this solution. So we are going to need fast pointer and slow pointer and 2 while loops. One while loop would be to find the point where both fast and slow pointer meets, and the next while loop would be to find the point where head and the slow pointer meets. So let's start coding. Oops. Alright, so now we are going to create our do while loop. So what are we going to do is we are first of all going to move each 1 step for slow and 2 step for fast. And our while condition would be until and unless slow is not equals to fast. All right, and in the next while loop we are going to find the point where the slow meets the head, right? So while head is not equals to slow, we are going to move one step for both head and for slow pointer. Okay, and finally we are going to return slow, or we could all return head as well, because both of them are pointing at the same point. So there's one mistake in this code that we need to fix, and that's that we are assuming that there is a loop. What in case there is no loop? If there is no loop, that at one point the fast would be equals to null, or the next of the fast would be equals to null. So in that case we will get an error. So we need to find the case where there is no cycle, and we need to return a null value in that case. So what are we going to do is, since this loop is to check for cycles, so we are going to check if fast is equals to null, or if fast next is equals to null. That would mean that at some point the linked list is pointing towards the null, and that point is the end of the linked list. So end of the linked list is pointing to a null value, so that would mean there is no cycle, so we are going to return a null. And if there is a cycle, fast is going to meet slow at one point, and then we are going to find the starting point and finally return the value. Let's run our code. All right, awesome. So all of our test cases were accepted. Let's submit it and look at the result. Great. So the time complexity for this solution is O of n, because we are iterating over each of the node at least once. So, and the space complexity is constant.